Hi students, welcome back. Coming to the next topic in the compiler design that we are discussing the symbol table. So let's see what is the storage location in that. The different ways to allocate memory. The data that will be stored in the memory, that is a storage location. So where exactly it will be storing and in which format the memory is going to be allocated to the device. There is the different ways to allocate memory in the compiler is the static storage allocation, stack storage allocation, heap storage allocation. So actually where exactly all these information will be stored, whatever the program that you want to be executed, that will be stored in the symbol table. The symbol table consisting of, it holds the information regarding the program. So and the compiler is having the different phases. So with the help of the symbol table, the information will be taken from the symbol table and the program is converting into high level language into the target language, that is assembly language. That is our concept. So the source program is in high level language and the target program is in assembly level language, that is the low level language. So in between here the symbol table is there. The symbol table is going to help is used to store the information regarding the source program. Okay, so whenever it wants to be these different phases are used to convert the high level language into assembly level language. So that is a compiler. So this concept we know that. Okay, so here the different ways to allocate memory. Whatever the source program is there, that source program has to be stored the information that the regarding the information of the program will be stored in the symbol table. So here the memory that will be allocated for this source program is of different ways. One is a static storage, stack storage and heap storage allocation. Now let's see what are the different storage allocations. Now first the static storage allocation. In static allocation, names are bound to storage locations. So we are talking about the first one, that is a static storage allocation. Here in this static, the names are bounded to storage locations. That is the first point. If memory is created at compile time, then the memory will be created in static area and only once. Static. So whenever at the compile time, first the memory will be created. In the compilation process is a symbol table, the memory will be created. So this will be in a static area and only once. So if you are using the static storage allocation. The static allocation supports the dynamic data structure. The thing is, it is going to, here the static allocation we are talking, but this static allocation supports the dynamic data structure also. That means the memory is created only at compile time and deallocated after the program completion. Okay, so first the memory is created whenever you want to execute the program, means whenever you want to convert the program. Here the execution means the conversion only. While we are talking about the compiler designs, means execution itself means converting, because we are in the first phase only, high level language to assembly level language. So execution comes under the that is the machine level language. You want the result. So here the memory is created only at the compile time and delocated after the program completion. Obviously, whenever the program is converted, its execution is over, its conversion is over, it automatically deallocates the memory. So that's why we are saying that static allocation supports the dynamic data structure. So it is creating, after the execution automatically it is deallocating, which is a dynamic nature. The drawback with static storage allocation is that the size and position of data object should be known at compile time. So this is a main drawback in the static storage allocation. While you are using this type of allocation, okay, so here before you have to know the size and position of the data objects whatever you are using at compile time. Another drawback is restriction of the recursion procedure. So these are the two drawbacks of using the static storage location. Now coming to the next type of allocation, that is the stack storage allocation. So what's the stack storage allocation? In stack storage allocation, storage is organized as a stack. means it is in the form of stack. Data will be organized in the form of stack. Okay, last in, first out. The activation records are pushed on popped. So whatever the activation records, that will be pushed onto the stack. Whenever the calling procedure is calling, so that it will be popped, pushed and popped at the top of the stack. The activation records contains the locals so that they are bound to fresh storage in each activation record. So the activation record consisting of the information that want to be executed at present. Okay, it's a live. The value of locals is deleted when the activation ends. So whenever it is popped means the activation is going to be end. Whenever it is end, all the local values are going to be deleted from the memory. It works on the basis of last in first out, and this allocation supports the recursion procedure. Did you observe that the static storage allocation does not support the recursion process, whereas a stack storage allocation will support the recursion process. So this is about the stack storage allocation. Now coming to the next one, that is a heap storage allocation. So these are the three different types of storage allocations. Heap storage allocation. So what is about the heap storage allocation? The first thing is, this is a dynamic storage allocation. Okay, heap is a dynamic storage allocation. Now let's see. It is the most flexible allocation scheme. Why we are calling it is most flexible allocation scheme? Because it is a dynamic nature. Whenever the allocation, the memory is allocating dynamically, obviously it is flexible allocation scheme. Allocation and delocation of memory can be done at any time and at any place depending upon the user's requirements. So that's why almost all the symbol tables will prefer the heap storage allocations. Why they use the heap storage allocation? Because the allocation and deallocation of memory can be done at any time and at any place depending upon the user's requirement. Heap allocation is used to allocate memory to the variables dynamically, and when the variables are on no more used, then it claims it back. So that is the main advantage of using the heap allocation. The heap storage allocation supports the recursion process. So the stack as well as the heap storage allocation supports the recursion process, whereas static storage allocation does not support the recursion process. Now let's see the simple example how this data will be organized in the symbol table. Okay, so let's take here, this is an example of on program where the factorial has to be stored. Each and every step has to be stored in the stack. Fact int n. If n is less than equal to 1, it has to return 1. So first it has to return 1. So next to element n star else n into factorial of n minus 1. So total up to factorial of 6. So the factorial of 6 will be placed on the stack. N is equal to 1, n is equal to 2. First it will be popped. Next it will be popped. Next this one popped. Like this. The top of the stack will be popped. So last element which is holding this value 720. Okay, when n is equal to 6, the factorial of n minus n 6 into factorial of 5 is 720. So these value will be popped and this will be the result. Okay, so whenever it is popped, the activation record is going to be ends. Activation ends. Whenever the activation is ends, all the variables will be deleted. All the local values will be deleted. So this is about the storage allocation. One is a static storage allocation, heap storage allocation, and the stack storage allocation. Thank you.